In this video, we will cover the mechanism of chronic transplant rejection. If you have not yet watched the acute transplant rejection video, please watch that first, as I will assume that you have reviewed how the donor MHC with small differences from recipient MHC can result in an immune reaction against self-peptides. Alright, let's dive into chronic transplant rejection. Chronic rejection is mediated by recipient CD4 T cells and differences in MHC between the donor and the recipient. At first, this may sound exactly like acute transplant rejection, but I assure you it is slightly different, and we will walk through the mechanism step by step. First, the key to chronic transplant rejection is that MHC class II on antigen-presenting cells presents peptides from endocytosed proteins from the environment. In chronic transplant rejection, as donor cells die, their protein fragments are taken up by recipient antigen-presenting cells and presented on MHC class II. If there are differences between donor and recipient MHC molecules, there will be different amino acid sequences. As the peptides are broken down in the lysosome, there will be fragments from the same region of protein that have different sequences. Let's revisit this process. Recall from the acute transplant video that the proteasome will chop up proteins into fragments about 9 amino acids in length. At the top, we can see the MHC class II protein from the recipient. It is broken up by the proteasome and presented on MHC for negative selection in the thymus. Fragment 2 of this protein binds to the self-MHC and therefore is presented. At the bottom, we can see another MHC class II protein. This is from the donor, however. When the donor cell dies, their MHC class II and other proteins are picked up by recipient cells and degraded into fragments in the lysosome. The protein fragments are then displayed on MHC class II for T cell scanning. Notice that although both the top and the bottom proteins are both MHC class II, polymorphisms in the population result in the peptide sequences being slightly different between the donor and the recipient. Although the MHC binding region is the same for both the donor and the recipient, the peptides presented to T cells is drastically different. The donor fragment 2 lacks the positive amino acids that recipient fragment 2 contained, and therefore the donor fragment will be recognized as foreign and T cells will react. This fragment was not present during the negative selection process because it came from the donor. Therefore, there will be T cells in the periphery which will react to this fragment, thinking it is foreign. Activated CD4 T cells are then capable of activating any B cells which express a B cell receptor against a portion of the donor MHC protein. Please refer to the video on adaptive immune activation if this process is still unclear. In this manner, the CD4 T cells activate B cells to secrete antibodies against the MHC molecules on the donor cells. This process is a mixed type 4 and type 2 hypersensitivity reaction where antibodies generated against the donor MHC eventually lead to vascular smooth muscle proliferation and interstitial fibrosis. The process takes a long time, and chronic rejection is classically considered to be rejection after 6 months. To summarize, chronic rejection is a form of rejection in which antigen-presenting cells present fragments of donor MHC and other donor proteins. When these fragments are different from recipient MHC fragments due to small variations in amino acids amongst individuals, CD4 T cells may become activated and help activate B cells to make antibodies against donor MHC proteins. These antibodies mediate chronic rejection in partnership with inflammation from activated CD4 T cells. We will end this video by comparing acute and chronic transplant. Acute transplant results from donor cells with donor MHC class I on their surface that present different fragments of the same protein due to small changes in the MHC binding site. Chronic rejection results from donor cells releasing peptides into the environment when they die. These peptides have different sequences from the recipient due to the genetic variation in the population. Donor peptides in the environment are picked up by recipient antigen-presenting cells and presented on recipient MHC class II. Differences in the peptide sequences between the donor and the recipient is responsible for activation of T cells. In both cases, the ultimate reason for rejection is the lack of donor peptides and donor MHC during the negative selection process in the thymus.